Good afternoon, everyone, and welcome to Lessons from a Factory of the Future, our virtual tour of Fast Radius and our discussion with its CEO, Lou Rassi. I'm Brad Keywell. I'm the founder and CEO of Uptake, and also a co-chair of the Executives Club Manufacturing and Supply Chain Forum, along with Barry McGoldrick from Molex. Barry and I are excited to co-sponsor this event, along with the Executives Club Innovation and Entrepreneurship Forum, which is chaired by Carney and by Baker McKenzie. So I'm looking forward to today's discussion, which will focus on innovative manufacturing and supply chain processes that fundamentally are designed to meet what is a very fast changing world that we all live in. So today we welcome Lou. Lou Rassi is the co-founder, CEO of Fast Radius. He will be our speaker today, giving us a virtual tour of their operations, which is a unique opportunity in this remote world to actually see and understand, not just hear. And we're going to discuss how companies are using the principles of Industry 4.0 to future-proof their supply chains. Moderating today's conversation will be Brent Ross, who's a partner at Carney, and also Michael Stoker, who's a partner at Baker McKenzie. So with that, I offer you and turn the microphone over to Lou and enjoy.
So Fast Radius, we're a software company that also makes parts. We're headquartered in Chicago. The company was founded by myself, my three co-founders, about 4 years ago. And we have been building and scaling something really special since, and I'm excited to share that with you today. Set the context a little bit for this world of manufacturing. We know it's important. Represents $12 trillion of the global economy, 15% of GDP, and about $1 trillion of that is in custom parts, which really is where Fast Radius focuses. We make parts for engineers and manufacturing companies using a range of technologies, additive manufacturing, CNC machining, and many others that we'll tell you about. But to set the context, we know manufacturing is a huge market and incredibly important part of how the world works. But there's a universal problem, and there's so much excitement about what is called Industry 4.0, new tools of digital design and digital simulation, new tools of additive manufacturing and 3D printing for the industrial grade. And there's so much excitement from companies across sectors to embrace those tools. But there's some challenges. The first is the infrastructure to move and make things today is very rigid and wasteful and inaccessible. And secondly, the product development processes are slow, inefficient, and outdated. And we'll talk a little bit about those. The model for how supply chains are set up today over the last 30 years, we've created this model where global supply chains have been set up with centralized mega factories, which are great for producing tens of millions of consumer electronics, but not accessible or efficient for meeting the needs of the time now. These mega factories have also created slow-moving supply chains where we fill shipping containers with parts. They sit on docks and on boats and on planes moving around the world, and in a way that's very slow and expensive. And then the other part of the structure today is we have these massive warehouses where parts are stored physically for sometimes years or decades at a time. So massive amounts of dollars tied up and just incredibly inefficient and wasteful. So that's the structure of how global supply chains and manufacturing models have evolved over the last few decades. The question is, what's next? And we've seen manufacturing evolve over the centuries. If we go back to the first industrial revolution, we had the steam engine power new ways of making and moving things. Then we had the second industrial revolution with the advent of the assembly line to produce high volumes of a product repeatedly to create new modes of transportation and new modes of efficiency for the world. And we saw a century's worth of benefit and prosperity that emerged. And then in the tail part of the prior century, we had Industry 3.0 with the electronics age. And this was the advent of the mega factories, and there was a lot of good that came from it, putting a supercomputer in everybody's pocket. But now we're looking at the challenges today, and this infrastructure doesn't meet what we need today. It takes many quarters or years to bring a new product to market. You have to be making many millions and millions of products to leverage the infrastructure of these mega factories, as opposed to democratizing access to innovators and product developers around the world. And we think that there is a new way as we reflect on this fourth industrial revolution with these new tools at our disposal. And we think we know what's next. We built it at Fast Radius. We call it cloud manufacturing. This is the first of its kind platform for manufacturing innovation that we believe will be as powerful and impactful as the assembly line from a century ago. This platform includes physical infrastructure to make things in a network of our factories and our partners, an operating system to orchestrate the production and movement of those goods, and then the first of its kind application and services layer to sit on top of that to allow companies to build apps and services powered by a cloud manufacturing infrastructure, just like we have over the last 20 years built this vibrant application ecosystem on top of cloud computing. The same type of thing is now happening in cloud manufacturing, and I'm excited to share a little bit about both the infrastructure in our factories and also the applications that are being built in this new age. I'll share an example with you to drive home the point of the promise of this new infrastructure and what's possible. Over the last year, we've all felt the pain in the pandemic of supply chains that have not been able to move fast enough to produce the products and distribute the products to serve the challenge we've all felt. Not enough ventilators back in March, not enough swabs through the summer. So many challenges to scale up production and distribute these critical goods. We had the privilege of helping companies use this digital infrastructure to rapidly design and make products in support of the pandemic response. One of the projects we worked on was with our partners at Carbon and Resolution. Over the course of just a couple of short weeks, a coalition came together to design a new 3D printed swab that was cleared by the FDA that could be used in the testing process. And over the course of a few short weeks, we were able to help with this validation and start producing hundreds of thousands of swabs to meet that critical shortage. The traditional supply chains were rigid. They were not able to scale up and flex. But with digital manufacturing, we were able to move incredibly quickly. And there are countless examples over the last 9 months about how this new way of designing, making, and fulfilling things can solve problems of scaling up quickly, providing access to new products to get validated and made and scaled quickly in a way that's just incredibly profound. And so as we reflect on this new era of manufacturing, we're moving from centralized mega factories to localized micro factories. And we'll give you a quick tour of our Chicago factory virtually here in a minute. And instead of slow moving supply chains with parts on containers moving on ocean liners around the world, we're able to move parts through the internet at the speed of light, producing them where they're needed. And then instead of massive physical inventory, where parts are stored on shelves and warehouses for years or decades at a time, now we have digital inventory where we can store the build package and instructions for how to reliably produce parts and store them digitally and produce them when they're needed. So an entirely new infrastructure for the manufacturing and supply chain industry that is flexible and sustainable and accessible for all engineers with a browser. So our vision at Fast Radius is to make an industry that is easier, smarter, and more capable and accessible for every engineer who wants to bring new products and ideas to the world. And so the solution we're bringing, we see, is we're building this bridge to the promise of Industry 4.0. I'll take a moment to share with you the cloud manufacturing platform that we're building. And there's 4 components to this infrastructure, and it's very analogous to cloud computing. At the bottom, you have the infrastructure to make things. These are our factories and a network of our suppliers, all digitally connected together. On top of that, we have a learning engine and a digital thread. A digital thread, think of it as the DNA of every part. We're capturing through our digitized workflow all of the information about how the part was made, from the temperature and humidity in the room to all the data off of the machine while the part is being made. All of that goes into a digital thread. Then we have a learning engine that's able to learn from every part that we make and use those lessons as the next parts come into the platform. On top of the learning engine, we have an operating system. This is how we orchestrate the workflow from first engagement with a customer all the way through to production and fulfillment. And then on top of that infrastructure, we have this application layer, the first of its kind for creating applications powered by cloud manufacturing. A couple of minutes to share a little bit more about our factory operations, as well as the software that we use to power our business and the cloud platform we've created. Now, each of our factories and our nodes of production are designed to drive industrial grade reliability and repeatability. And also think of them as a factory in a box that can be copy and pasted into other locations, digitally connected to the nerve center in Chicago to allow us to create this distributed and decentralized global production network. That's what we're building at Fast Radius. We have factories now in Chicago and in Louisville, and are excited as we look for the road ahead to build our network more broadly. To bring this to life, I'll share a couple of examples of work we've done with customers, and I'll start with Aptiv and Ford Motor Company. They wanted to bring a new product variant to market that required a different tow package. Traditionally, they would have had to injection mold a bunch of components. It's time consuming, it's costly, and was not worth the investment, and they weren't able to move fast enough. And so they approached us and said, look, can we create a 3D printed electrical connector that could be validated and certified to be put on the vehicle? We worked with them to do that, and now there are many components that are out there driving on trucks and cars in a way that is happening for the first time. The technology for additive manufacturing has been around for decades, but only recently has it crossed the chasm where the economics and the reliability of production from our micro factory and this industrial infrastructure made it possible to really put these parts on vehicles that are out there. And the benefit for Ford is they're able to bring more custom product variants to their customers and accelerate their product development process and time to market. When we think about how software powers that, our platform, a cloud manufacturing platform, allows engineers to upload parts. Some of the feedback is automated, and some of it is they can provide kind of a conversation with experts on our team and their teams, where they can drop a pin, ask about a feature, get feedback on that feature, and creating a modern digital way of engaging in their work. A second example we'll share is with Curtis Motorcycles. They're a pioneering company bringing electric motorcycles to the market. They approached us, not being manufacturing or supply chain experts, but being design and motorcycle experts, and looking for a partner that could help them figure out what are the right technologies to embrace, what are the right materials to embrace, and how do we quickly get those scaled into production in a way that the cloud platform enables. Now we have over 60 components that we're manufacturing that are a part of the bikes that they're bringing up and scaling to market. We're able to help companies like Curtis move quickly through tools on the cloud, and they include an automated manufacturability check. The part that you see here, a customer can upload it, and our algorithms deconstruct every component of the geometry and then run it up against design rules. We have a library of rules that gets smarter every day. We're learning from every part that we make, and those design rules then screen the parts and can flag issues on the parts that may make them unmanufacturable or make them at risk in manufacturing. All of that knowledge is codified in our learning engine and shared with our customers in an automated way. And you think of the power of that. It's a century's worth of manufacturing knowledge that we're now making accessible to every engineer. And again, every day it gets smarter and more capable as more technologies, more materials, and as our digital thread gets richer and richer. Once you've designed the part, there's a modern e-commerce experience, much like we all love in our consumer lives, where you can go ahead and order your part. You select the technology that you want, the materials, the specifications, the quantities, the shipping address, and creating a modern digital experience for manufacturing companies to engage with supply partners. And once this order is placed, it goes into our digital workflow for our factory to start scheduling the work and start making the parts. The last example I'll share is with Airbus. We worked with them to create a first of its kind virtual warehouse for them, where the parts you see here on the right are used to repair aircraft, and they used to store them for years at a time, and not have them in the locations that they would ultimately need them for the repair. So look, let's create a digital warehouse, a digital inventory, and Fast Radius can produce them on demand when they're needed. We took the time from getting parts where they need them from many months to using our cloud platform to just 48 hours. And it speaks to the speed that can be unlocked from embracing this new digital manufacturing and supply chain model. The screen here just shows the latter part of our digital workflow, where once that order is placed, and so look, I need 3 of these, 10 of those, it starts working through our factory in every step, from scheduling through production, thermal processing, post-processing, every step in the process, all the way until the part is in our customer's hands. So that gives you an illustration of some of the services that are running on the cloud today. I think what's really exciting is to take a look around the corner and say, where will cloud manufacturing take us in the next 5 to 10 years? One of the applications we get really excited about is this AI assistant. And I shared with you how we're building this learning engine library of design rules. Well, imagine how smart that is going to be as millions and millions of parts get fed into the learning engine. We add in conversational AI and say, what's the best way to make this part? How long is it going to take me? What is the carbon impact of making this design choice? These are the next generation tools that will allow engineers to make better products faster. And Fast Radius is building the infrastructure to power that. Another example is the evolution of the virtual warehouse. Here you see one of our future customers, where they're able to put on some glasses and scroll through an endless library of parts that they can learn from and embrace in their next generation product. Now, we think that's important for companies in general, but to share a couple of examples about strategic virtual warehouses that we can be incredibly profound for the human condition. Think about the Strategic National Bank of critical components to respond in a crisis. Now, before the pandemic, we didn't have ventilators in a virtual warehouse. We didn't have swabs in a virtual warehouse, but now we do. And now, the next time this a crisis emerges, there's an opportunity to hyperscale production to meet the needs of the people that we want to support. And that's here at home. And as we think about looking forward and wanting to explore the stars and over the next decade, put people on Mars. How are we going to do that? We're not going to be able to take everything they're going to need up there with them, but they're going to want a virtual warehouse that will allow them to produce the parts when they're there, when they're needed, in a way that supports that exploration. So the power of the virtual warehouse, we think, is incredibly profound if we look over the coming decades. The third example of what we see coming and what we're building is what we call the fourth modality of logistics. Now that we have a few nodes in the network now, over the coming decade, there will be many, many more, all digitally connected and orchestrated. It creates a new way of moving parts around the world. We call it the fourth modality because through human history to date, we've moved parts 3 ways: by ground, by air, and by sea. And I have a fourth mode, which is moving parts through the internet at the speed of light. And we are certain that the impact of this fourth modality of logistics will be as profound on the human condition as those earlier modes of transportation. And that's the infrastructure that we're building at Fast Radius. Our purpose as a company is to make new things possible to advance the human condition. We believe manufacturing is not just important for the things that we make, but the things that we make possible. It's not just about the cars, the planes, the satellites, and the cereal, but it's about making the world more connected. It's making the world more healthy. It is solving problems. It's feeding and powering the world with the things that we make, and that is really important work. We're grateful to have the opportunity to build and scale our company in service to that cause. And I think that's it for the formal presentation today, and then we're going to open it up for some Q&A.
Great, thanks, Lou. I thought we'd start off by going back to the beginning, so to speak, and talking about your personal journey before we dive into the Fast Radius story a bit more. So like me, you're from Detroit, your family's been involved in auto for a long time. Just interested to hear how this shaped hobbies and interests and choices you've made academically and professionally.
Yeah, Brent, so I as you mentioned, grew up in Detroit. I'm a third generation car guy. My father still runs a machine shop in Metro Detroit serving the auto industry, and that's where I grew up as a kid. My first job was as a maintenance guy and speeding up chips and cleaning up the factory. From my earliest days, I had just drawn to this ability to imagine something, sketch it, draft it, and make it and bring it to the world. So it captured my imagination very early, and I think my family instilled in me an appreciation of just the importance of the things that we make. They help people heal, they connect us, they allow us to explore. And so I think that was instilled in me very early and inspired me to be a mechanical engineer by trade. First chapter with Chrysler and BMW, designing cars and engines and factories. And then at McKinsey, I was at McKinsey for almost 12 years. And I had the opportunity to lead a global effort looking at the future of manufacturing, where it's going, what it means for how companies and countries are going to compete. And that really helped to plant the seed for Fast Radius and form the thesis for what we believe is the next century's industrial infrastructure. But it all goes back to those early days with my family for sure.
Thanks. One of the things that the Innovation Forum is often interested in is how did you know that this was a hole in the market you could fill? And, as you were going through that process, how did you make decisions about, where you should be based and, why you should find a home in Chicago?
Yeah. I think the thesis was formed through that whole journey that I shared. I think going back to realizing how important it is to make things, but also the pain in the process, the challenges in the process, and that the first chapters of my career, the inefficiencies, and then seeing all of the ways it became so easy in the digital age to get the things that we want. I don't know, Brent, what's your favorite snack?
I like apples, almonds.
Apples and almonds. All right, so if we wanted to get you some apples and almonds, we can go to any number of apps on our phone. We can push 5 buttons and we can have apples and almonds delivered to your front door in the next 30 minutes, right? Yep. Over the last decade, we've just come to expect these types of delightful experiences. The industrial world isn't operating that way. It's archaic. If I want to get a custom part made, I've got to make 15 phone calls. I'll wait 5 weeks, and it is not caught up. So I think for me, the thesis for Fast Radius was shaped by my early days appreciating the importance of it, seeing the pain of it, and now recognizing the power of digital technologies to create entirely new experiences. I would also highlight that it really came to shape with my founders of Fast Radius, Bill King, John Nanry, Pat Cusker. There were 4 of us that came together and through work together. One of my co-founders was the CTO of the National Lab here in Chicago, DMD, now DMDII, Digital Manufacturing Design Innovation Institute, now called MXD. And we came together to help write the proposal that brought the National Lab to Chicago. Bill stepped in to be the founding CTO. John Nanry, our co-founder, worked alongside us there in standing up that plan. And to your second question about how we landed in Chicago, really there was an ecosystem that was created here for the future of manufacturing and industry, and it drew us together. And I think coming from that, others around us, and was the right place to plant a flag.
Yeah, that has been exciting to see. You talk a lot about the platform that is Fast Radius and all the things it can do throughout different, stages of the life cycle, from design to prototype and use fulfillment. And you've also talked about, the cloud capabilities, additive manufacturing, support for legacy production methods in some cases. Just interested, as we think about, all of us, how to engage Fast Radius and how it can help our businesses and our clients. How do you think about the scope of services and how it differs from things pre-industry 4.0? How should we think about it?
I think there are really three service offerings that we have today that I think illustrate ways of engaging. I think one is if you want to produce parts with any technology, machining, molding, additive manufacturing, and you're looking for a modern way of experiencing that and having a modern supply partner to work with you, we have our on-demand offering. You can upload a part, get immediate feedback, also engage with an account executive or expert as you need to through that process, and it becomes really easy to start that flywheel turning. Could be for a small opportunity, could be for a larger opportunity like we're doing with many of our customers, but it's a way to get started in a way that's really easy. Upload your part, start to get insights, start to engage. A second way is if your business is really excited about next generation additive manufacturing or 3D printing specifically, there's another pathway. Similarly, you can upload your information and we can get a flywheel started, but we can bring insight and expertise to bear as you're thinking about applications for where additive manufacturing can really help your business. That's a second way. And then a third way is you're thinking about supply chains. You say, look, I'm tired of storing stuff physically and I want to explore, like Airbus did, how do we create a next generation digital supply chain solution? There's kind of a third pathway to start to engage. But I think what we're excited about, Brent, is the platform is driven to drive accessibility. Just want to put these tools in the hands of every engineer, much like cloud computing has, right? Think about 20 years ago, how difficult it was if you didn't have on-premise compute, for smaller companies to really scale up and experiment. Where now, any company, any engineer who has an idea can access world-leading compute power right at their fingertips. And we think what we're doing is empowering mechanical engineers, manufacturing companies to put world-leading manufacturing tech at their fingertips with a digital workflow and experts and people to support.
Yeah, it's a real supercharger for small companies, especially, I can imagine.
Yeah.
You give some examples of the last recent months in the pandemic and the things that Fast Radius did and is doing to help, not only in the current crisis, but for future crises with the, with the virtual bank, the cloud bank. But could you also maybe share any other examples or talk about maybe what you learned and in this environment that really is a lasting lesson for you and your clients?
Yeah, I think a premium on the ability to move quickly has been really amplified through the crisis. And as much as we enjoyed the efficiency of these mega factory models and the many benefits that came from it, putting a supercomputer and a device in everybody's pocket that can be afforded, it's a phenomenal impact of this last era of manufacturing. But the rigidity of that, the lack of access to it, and also the wastefulness with it, I think we've just really felt that over the last 9 months. And really, I may be biased, that's part of the thesis of Fast Radius. We know that is the case, that rigid and wasteful manufacturing models, that doesn't need to be that way. And so the swabs example, designing a product and launching it and at real scale and with our partners at Carbon Resolution happened in weeks, what would have taken years. And we saw that many cases. Other examples about creating the ability to share information. We saw digital platforms where people were uploading designs for face shields and masks and other things that would have been really hard 5 years ago to do, but now in a digital age, those collaboration channels were created on the spot to support this fostering of knowledge sharing. So I think there is such an appetite for this next generation infrastructure to share knowledge, get access to knowledge, to move more quickly. I think that for us is just a call for us to go faster, build this infrastructure in a way that it can empower more and more people and companies.
Oh, Michael, looks like you're still on mute there.
Sorry. Hi. So I have a couple of questions based on the typical project life cycle from design to fulfillment, and some questions around speed. Is there a typical time that it takes for, if I'm a new client and I have a project for you, and what should I really expect in terms of that project life cycle, and how quickly you might be able to respond to my needs to get that that part procured quickly?
Sure, Michael. So of course, it really depends on the sophistication of the part. There are some cases where we'll get a customer say, look, I need 15 or 150 of these made next week. Can you help us? In that case, we can. If the design is locked and there's not a need for a lot of changes and iteration, we can start producing parts the same day we engage with our customers and they upload the parts. Run the design checks. If necessary, experts engage in the process to clarify questions, and parts can start being produced the same day that our customer approaches us. There are other cases where someone says, look, I really want to design a breakthrough product with additive manufacturing that's going to require engagement and iteration and design, and they want to engage more deeply. And like we did with Aptiv, and there it was a certification process where we had to certify that every part that was made for these electrical connectors is being made the same way to the same spec, regardless of where they resided in the build platform, regardless of the machine that was making them. So doing process capability studies, and that's one of the, as you would in your traditional automotive manufacturing. And so we've created a model where we can do high velocity on-demand work, and also ongoing, reliable, certified production that serves the auto industry, aerospace industry, medical device industry. And so there's really those two pathways depending on what's needed for our customers. But it can move quickly. But we also recognize that to certify parts that are going to go on cars, go on medical devices, that there's a natural life cycle for our customers to go through to go through that certification. And for many of our customers, Michael, we're the first supplier they've certified for many of these new technologies. Polymer additive manufacturing is an example.
Are there other steps that Fast Radius has taken to improve speed to get parts out to the customer quickly? I think I caught in the presentation that you have facilities, a manufacturing facility co-located with UPS. Is that correct?
Yeah, we're really excited about our partnership with UPS, particularly as we reflect on this next generation logistics infrastructure. So we have our factory on their campus, on UPS's campus in Louisville, and allows us to produce parts late into the evening and then get them anywhere a plane can fly the next morning. And I think an example of the kind of partnerships that are so important as we look to build the infrastructure out.
Now, you mentioned that you do work for lots of industries, automotive, aerospace. Are there any industries or applications that are particularly well suited for cloud manufacturing, or any industries or applications that aren't so well suited for on-demand manufacturing?
Yeah, I think for where our scope is now, we're not making pharmaceuticals, we're not making food, so it's kind of can carve out those things. We're making precision manufactured components with CNC machining, injection molding, additive manufacturing, sheet metal fabrication, and so our core today, Michael, is in those technologies. But look, as we reflect over the coming decade, across every type of manufacturing, there is an opportunity to do it much more efficiently. The digital-driven workflow, a delightful customer front end, I think it's just a matter of time for this cloud manufacturing model to expand. But that's where we are today, is where the things that are most appropriate. I also think that the sweet spot from a volume perspective, if we're looking to make tens of millions of a simple widget, where it's just every day it's the same thing running, we're less focused on those hyper high volume types of products, but more in the mid to lower volume that kind of covers 80% of the manufacturing world. But that's another kind of segment where we're probably not the best suited, where they want to invest in kind of high volume infrastructure that's different than where we focus.
Mm-hmm. Can you talk a little bit about sustainability and environmental sustainability with respect to fast radius? You mentioned it in your presentation, but how has fast radius really embraced sustainability in its mission?
I think it's a big part of it, Mike, and thank you for bringing it up. It's very inefficient. It's traditional supply chain models. You're moving parts on containers. You're flying them over the air. You're sometimes a couple of times around the world for an assembly, and then you're storing them, right, in boxes. In many cases, the obsolescence costs are every year we're throwing parts away that are unneeded. And that's just wasteful, and we were mindful of that as we're building our company, that this is a big benefit. In addition to helping companies bring innovative products to market better and faster and more economically, it is good for the planet. And so we've seen examples. You're making better design choices about the technologies to use, the materials to use, can reduce the CO2 impact by 50% of the choices that you make and how you design the part. And then the benefit of making a part locally instead of flying it all around the world and back again has just tremendous impact in the carbon footprint of the industry. So it is, when we started building the company and scaling the company, for sure this is on our mind, and we're still in the early days of achieving the impact. But if we fast forward over the coming decade and look at the impact, these more efficient and sustainable ways of designing, making, and moving things, it is something that's important to us for sure.
I'm going to jump in with an audience question here, Lou, if that's okay. So questions on emerging technologies, and specifically the question calls out blockchain and how it can be important in cloud manufacturing, or Bitcoin as a form of payment, or even any other emerging technology that you think is going to be important to cloud manufacturing as it evolves.
Yeah, so many technologies are relevant to cloud manufacturing. I think I'll start there and we'll talk blockchain. Our Industry 4.0 is a very broad umbrella. It includes everything from new tools of digital design and simulation and high performance compute to optimize geometry and then to do simulations on that, kind of upfront design work. There are new tools in manufacturing, 3D printing and the next generation CNC machining and intelligent machines and sensor inside to do immediate response and adjustment, and how those devices are being monitored and then providing real-time feedback, and some of the great work that Brad and his team at Uptake are doing in monitoring industrial equipment. And so there's so many pieces of technology that are available, so many components. What we have found, and we're so excited about it, is we've stitched all of those together into our operating model that allows them to benefit something very tangible, which is making something reliably, quickly, and putting it out into the world. And so, yeah, we are so excited, and there are dozens of examples of Industry 4.0 technologies that we have employed in our workflow, and all along that workflow, from upfront design work and discovery through production, through metrology, and ultimately in fulfillment and tracking parts. Which is why there's so much to be excited about, and over the next decade, that those innovations are only continuing to mature, and they'll make our workflow and make the cloud manufacturing platform all the more powerful. With respect to blockchain, I think there's a lot of excitement. It's not something that we have leaned into, but just as a hobby observer, there's an opportunity for secure data exchange, and that as a vehicle for providing that assurance for the movement of products, for the provenance of how a product was made, the kind of the DNA of a part, and using that to provide that assurance, which can be really, really exciting. But candidly, I think still early days, but it's one of the many innovations that are out there give cause for excitement.
Now, Lou, with respect to the fourth industrial revolution, which I think is a fascinating topic, if you could, hold a crystal ball and kind of sort of look into the future, what would fast radius, in your opinion, look like 10 or 15 years from now? Do you think it'll have the same operating model, or do you think some of these new technologies will greatly, change the way that fast radius operates?
There's so many ways that our model and business can evolve. Mike, I think I'd offer a couple of reflections. I think we see our footprint expanding for sure, into other geographies, into other technologies. And with that physical network, all digitally orchestrated from the nerve center in Chicago, with a learning engine that is building from every part that's made around the world, the power of that we think is profound. I shared 3 examples of what we see: cloud manufacturing power with the AI assistant on every engineer's shoulder, this virtual warehouse to power exploration and crisis response for the world, with the ability to move things through the internet on a fourth modality of transportation. That's profound. And it's just, this infrastructure is waiting to be built, and that's what we're leaning into and what we're doing. And I think that opens up all kinds of opportunities for our business model to evolve. But fundamentally, we're making products, and we're providing insight and experiences to customers who want to bring physical products to the world. And we work with them across the life cycle, from discovery through design, production, and fulfillment. And I think over the coming decade, we'll broaden the footprint for how we can serve our customers, as well as the software tools that can power every step of that journey, bringing them insight and to make better decisions in what they do. And I think the result of that will unlock entirely new industries and ways of making and moving things for the world. And this is the infrastructure to power that.
Lou, we have an audience question, and this question is about partnerships in particular. How does Fast Radius how do they partner with other companies? For example, precision machine shops. Do they ever join forces with Fast Radius? And what are some of the pros, cons, barriers for partners that want to work with Fast Radius?
Appreciate the question. And partnerships are so critical. We can't do this on our own. I think in every aspect of our business, we are looking to expand and strengthen our partnerships. It's been important every step of the way. With regard to CNC machine shops, we do have suppliers that we work with that are a part of our foundational network. Some of the work we do internally, much of the work that we do, we will partner with suppliers, and we expect that to continue. Our model is to work with a curated set of supply partners who are excited about our thesis of building a digital-driven workflow that creates transparency and a high velocity, high quality production model, and embracing these tools of Industry 4.0 at each step of the journey. So we are actively, absolutely looking for partners to build with us. And that's in our supply network, machine shops, molding shops, stamping companies across the board, but also in the software ecosystem. As we look to develop next generation tools that sit on top of this infrastructure, and also with the machine companies themselves. We have wonderful relationships with the likes of Carbon and HP, who are pioneering new 3D printing machines and materials, and so many more that we also are excited about. And so I think the mindset for us, Mike, is very much partnerships is how we can drive greater impact faster, for sure.
Thanks, Lou. One more question, if we've got time for one more. So my question is, thinking about what has made Fast Radius successful and what drives the culture there, and thinking also about, how it applies to other businesses or other industries. What do you think is part of the I guess, the secret sauce that's helping you either sift through technologies and decide what to select or decide what to prioritize, broadly speaking, to keep the company innovative and serve clients effectively, keep you at the forefront there?
I think at the heart of our success is the purpose that really gets us all out of bed every morning, which is to make new things possible to advance the human condition. Like, that's really what drives us. The people who come and join our journey, they believe in the importance of this work and the opportunity in front of us to make this industry better, and in doing so make the world better. Like that rallies us. And there's some day-to-day challenges for sure, but I think there's what's the special thing about our culture that I am so grateful for is that foundation, the culture that really, purpose that really drives us. I think with regard to how do we stay at the cutting edge from a technology perspective, we invest in it, and we invest in people who can figure it out. And so I mentioned our chief scientist, Bill. There's so many folks on our team that are world-class technologists, world-class software builders. Gus is our chief product officer and software leader. He built Magic Leap and a number of other great technology companies. We have in our commercial organization, we have people who have built and scaled successful tech companies. So at each part of our business, we're being purposeful and investing behind leaders and people up and down the organization to really navigate the way, because it is not doing what we did as an industry a year ago or 2 years ago. It's just moving so quickly, and so we bring motivated people in and give them the opportunity to explore and innovate and try and do that all together.
That's a good note to end on. Thanks, Lou. I'm going to turn it over to Barry now for closing remarks.
I've got multiple things to hit here to take myself off mute. Can everyone hear me?
Yes, Barry.
Okay, thank you very much. Just 1 second. So good afternoon, everybody. I'm Barry McGoldrick, and I'm Vice President and Chief Procurement Officer at Molex, and a fellow co-chair with Brad Keywell of the Manufacturing and Supply Chain Forum at the Executives Club. And I really think we had a fantastic discussion just now. Really want to thank Megan for helping set this up. Thank Brad, Brent, and Michael. But a special thanks, I think, really to Lou Racy of Fast Radius. A really a great update for all of us, and great to see such innovation taking place in our own community. I think all of us as long-time industry professionals, I think we've all seen firsthand how changes in disruptive technologies have propelled our work forward. And for me personally, I had a couple of key takeaways. First of all, we cannot stand still. We need to continually innovate across all dimensions of our supply chains and be open to new concepts with a view to understanding, and I think Ron put it well, what's next? There's always something next. I think the second kind of point, and I think this is very true for us here where I work at Molex. Secondly, I think data is our friend, and I think the importance of having an intelligent digital supply chain that's connected from the customer all the way through design, manufacturing, fulfillment, and the inbound supply chain is critically important. I think this data and connectivity can deliver insights that help reduce cost, improve efficiencies, enable scalability, flexibility, as well as agility that ultimately lead us to a happier and stickier customer relationship, as well as more profit for all of the supply chain stakeholders. And again, you know, it's something I really took from Lou's presentations, and it's something I think that we look for in all of our supply chain partners. I think we hope you found this information helpful to carry you through the rest of your week and beyond. Megan has asked me to remind everyone to keep an eye on the Executives Club website for more upcoming virtual programs. In particular, we hope you can join us on Tuesday, February 2nd for another joint forum event that's called Data to Dollars. And that's going to be focusing on data monetization and best practices. and you can sign up online on the executivesclub.org website. With that, I hope you all have a wonderful rest of your day. Thank you again for all joining us, and hopefully see you all soon. Stay safe and see you soon. Bye now.